morning, everybody. I am recording this video on Tuesday, November 7th, but this is recording the lesson for Wednesday, November 8th, just because I want to make sure I get it done since I'll be back in school tomorrow, and I know it's going to be a crazy day, so I wanted to make sure and get this in just in case, just to make sure I can have that ready to go for those of you who are not going to be in class tomorrow. Okay, so we're on day 2 of our plate motion engineering internship. If you are absent on Tuesday, it is imperative that you understand what we're doing. So go back and watch the video from Tuesday if you didn't do it already. And then you can go ahead and watch this one. You have to understand what you're doing with the plate motion engineering internship before we can go ahead and begin. Those of you who were here on Tuesday, you know what we're doing, and so let's go ahead and get started. Number one thing is I want you to go into Amplify. You're going to go into Plate Motion Engineering Internship. Click on Day 2, and in activity number 1, there's this blue space for you to open the Futura workspace. Select the Plate Motion Engineering Internship. It's the purple one. And then you're going to read the daily message from Hannah. Okay? So this is what the message says. First of all, a daily message tells the focus for each day during your internship. It's like if you were going to work and the very first thing you have to do is you turn on your computer. This is true. This happens every day for me. You turn on your computer, you look at your emails, and you make sure, is there anything going on today that I need to be aware of before I begin my day? So that's what you guys are doing here. Hannah will send you an email or a message every day. So every day we log on, every day we look at our daily message. And she says, "Welcome back, interns. We'll continue researching tsunamis today." Engineers often do research by reading and by building physical models. Do you remember when we watched the video about how the different scientists, different geologists thought the Grand Canyon formed? And there was that one professor that built the physical model to test his idea of how the lake overflowed and created the Grand Canyon. So that's what she's talking about. Very often, engineers will also build physical models just to make sure, just to test their ideas. Today, you're going to use a model to better understand how tsunamis behave. Then you'll return to the dossier for today's reading, which is about plate boundaries and how their movements can cause tsunamis. By understanding how tsunamis are formed, you'll be able to design a better warning system. While you're working today, think about the following focus questions. Question: what is the relationship between plate boundaries and tsunamis? You'll need to figure this out before you can start designing your warning system. So your deliverables, there are 3 of them today. First of all, you have a modeling a tsunami wave sheet in your folder in GoodNotes, or your folder in Schoology today. We're going to get there in a second. I'm going to have you put that in GoodNotes. You also need to have some annotations for chapter 3. That is the title of that chapter is Plate Motion and Tsunamis. And then I kind of want you to go back to chapter 2 and look for information regarding plate motion and tsunamis as well. So I'll make sure and give you that information at the very end of the class slides today. So we've got 3 things that we need to make sure that we can get to. All right. There's a tool in this, in your plate motion Futura workspace, and that's sort of to keep track of important information. So in your Futura workspace, look down on the bottom left, and it's got this icon with a pencil and a paper, and it says New Note. Go ahead and select New Note, and you're going to create a blank note. And so I'm going to give you an example on the board of how to record your daily message notes. So it's a good idea not only to read your daily message, but also say, okay, it's kind of like making a list of things to do. It's your homework assignment, but it's also like, what did we do today? What do I have to get done today? So we're going to give our note the title, and it is Day 2, Understanding Tsunamis. So go ahead and record today's date, so 11/8, and then write the subject of the message. So Day 2, Understanding Tsunamis. And then I want you, below that, I want you to document all the important information that we need to record from today's daily message. So you are going to write underneath that, modeling a tsunami wave lab sheet. That's the first thing that we need to do today. We're going to get that done in class. If you were gone today, this is an actual hands-on lab that you need to talk with me and make sure that you have a chance to complete this when you get back. I also want you to write down a couple questions to kind of focus our research today. First of all, do all earthquakes cause a tsunami? So when we do the reading and you read and you annotate, we're going to see if we can find the answer to that. And then you're going to do that by skimming through chapter 2. Specifically, you're going to read the last paragraph of chapter 2. And then I want you to read and annotate chapter 3. Okay, so make sure you get all of that written down. If you need to pause the video so you can finish, do that. And then go ahead and move on. So for each daily message, you're going to return to your daily message notes to add new information. So we'll do it again tomorrow. All right. So now we're going to model a tsunami wave. I want you to remember that your task overall, you are working for Futura, and Futura has a client, the World Ocean Association. I can't remember. WOA. They have asked Futura to give them early warning systems, and you are competing with your fellow interns to create the best design for an early warning system to help people evacuate in the event of a tsunami. So I had the kids put away their iPads at this point in time because we didn't want them to get wet. I'm going to describe what we did, and then when you come back, I'm going to have you do this, okay? Just a reminder, yesterday you learned from your reading that a tsunami is a large ocean wave caused by a sudden shift in the seafloor. That's when the seafloor sort of pops straight up, vertical, right? It's not a side-to-side motion, but it's when it's that vertical moving or shift of the seafloor. So I've got a video I want you to watch, and this is just a computer graphic showing two different visualizations of a tsunami in the Indian Ocean. And notice that both views show Sri Lanka, the area that is your warning system. Sri Lanka there is circled in the top left. It's just that little small island off the coast of India. And so let's go ahead and watch this first video. A couple of things I want to show you. In view number 1, we see that the earthquake is generated there off the coast of Thailand. And you can see that first wave right now as it's crashing over Thailand. And you can imagine the devastation there. But I'm going to have you watch that again. I'm going to go back and show you view 1 again. We read about tsunamis having like the first wave and then sometimes the second wave. So you can see that first wave is huge, but then right behind that, you see that second ripple. And that's the second wave that often hits. And so it's not always just one. Okay, so that's the first one. Here's the second view. And this one I think is a little bit easier to see, that first and second wave. So that kind of red and yellow is the first wave. Second wave would be the blue right behind it, so you can see that a little bit better. I'm going to show this again to you because I want you to understand when the earthquake occurs, it occurs right here off the coast of Thailand, okay? That plate pops up, right? And it's like the energy that comes from that motion, that plate motion, it's not a directional, one direction energy. Energy, it goes, like when you drop water in a bucket and it creates a ring, and those rings kind of go out, right? It's the same thing. Have you ever heard of the epicenter of an earthquake? The energy from that earthquake or from that plate shift, that plate motion, it'll start in one location, but the energy travels around it equally in a circle, kind of, right? Just like a drop in a bucket, how you would see those concentric rings. And so you'll notice that to the right, there's just to the left, there's just water, there's ocean there. And so the energy is picked up by the water and there's nothing to break it up. There's nothing to stop it. And so it just continues across the surface of the ocean. Whereas there's land to the right of Thailand, and that kind of breaks that up again. So I'm going to play this one more time, and I just want you to watch how that starts. Here we go. And so you'll see that it just sort of ends to the left, but to the right, it just continues. And even, as it continues across the Indian Ocean, boy, it's just so much energy, and it goes all the way over even into Africa. So it's quite a lot of energy. So tsunamis can travel far across the ocean. People may be at risk of being hit by tsunami, even if they're too far away to feel the earthquake that started it. So warning systems are very important. And these tend to travel really, really quickly. So it's important that our warning systems are accurate and that we get as much warning as we can get. So in class, we had a model. Okay, the system of this model is I had a black paint tray, and we had, like the little houses from Monopoly. We've got those houses, and I have a transparency sheet that's taped on the inside of that paint tray, and then I've got some straws. And so we're going to be modeling an ocean wave and a tsunami wave. And then we've got these worksheets that you need to fill out. Now, the kids worked in a group of 4, and I'll try and make sure that I can get somebody to work with you when you come back. And if not, then definitely I'll be your partner to help you out, okay? So we filled these out. I'm going to go really fast because I don't want you to necessarily see all of this. And then anyway. All right, and then we filled that in. And then the last thing that we did is that we read about plate motion and tsunamis. And so we just need to continue our background information, our background research by reading and annotating chapter 3, which is called Plate Motion and Tsunamis. I had the kids number each paragraph in chapter 3 because we're going to come back and we're going to talk about this tomorrow. It's pages 7, 8, and 9. And just go ahead and number those paragraphs. Really make sure that you annotate, especially having to do with those questions like do all, hang on, let me get to that slide. I'll tell you. Here we go. Does plate motion always cause tsunamis? In other words, every time plates move, does that always cause a tsunami? Is there one type of plate boundary that's most likely to cause a tsunami? In other words, divergent plate boundaries, convergent plate boundaries, transform plate boundaries. Is there one type that's most likely to cause a tsunami? And do all earthquakes cause a tsunami? I think I want that last part, if not which ones may cause tsunamis. I think I want that up here at this second bullet. I got to change that. If there's only one type, which one is it? All right. So read the last paragraph of chapter 2 and then read and annotate all of chapter 3 with these questions in mind. And I will get you caught up on that lab to make sure that you get that worksheet filled out completely. All right. Okay, you guys, talk to you later. Have a good day.